talk about the inheritance property in Python programming language, okay? But firstly, we need to analyze another advanced math operation. Firstly, in order to do that, we need to import some specific libraries, the random or the import pandas as PD, and import the open pyxl and import matplot lib.pyplot as plt. Okay, so this is the visualization or the demonstration of what are codes in the advanced math operation class. Okay, firstly we need to create the advanced math operation class in here like this one, and so def init function should be defined with the values of the value. Okay, and so we can easily initialize the whole values which is coming from the creation of the advanced math operation. Okay, and so self value creates the value. Okay, this value is the variable of the class possess this value, and so this value is also add arguments or the parameters of the init function calls. Okay, and so we can create the add body in here in order to overload our function with other class parameters like this one, and so result can be assigned with the self value plus other value. Okay, and so we can return the advanced math operation with the result value. Okay, and also we can add the def multiplication self and other can be given in here like this one, and so result self value times other value. Okay, and so we can return to the advanced math operation result in here like this one. Okay, these are the basic class. But how about the another properties or the another functions? Firstly, we can generate the random dataset with the size value. For example, dataset can be initialized with the empty list in here like this one. The for I range size can be given in here like this one. The value is the random, is the generalized import library, which is the uniform can be called in here with the definition of 0 to 10. Okay, and then the dataset append can be called with the advanced math operation value. Okay, we can just pass this value into the append, but if we can do or we can use this advanced math operation, these operations automatically defined in in this class, and so these properties can automatically be called or used with with this dataset or within this dataset. Okay, this is why important to define the class structure in in Python programming language. Okay, and so we can return the dataset like this one. Okay, and also we can create the right dataset to Excel file in here like this one. The dataset should be given and file name should be in here, and data can be defined with the value keywords with the item value for item in dataset, and so each dataset values which assigned to the item, and this item dot value should be assigned with the values, and so this data is a dictionary value. And so how can we convert this dictionary value to data frame? By using this term, PD has a specific properties and the functions in order to write any file to the Excel, and so this data frame converts this data to the df or the pandas type, and then we can write this df to the file name with the index values of the false. Okay, and so we can write the whole data to the Excel by using this function, or we can also create the read dataset from Excel. Specific file name should be given in here like this one, and df pd read Excel can be called in here like this one. The file name should also be given here, and so this dataset can be initialized with what the advanced math operations values. But which value? For value in df with the keywords of the what the values. Okay, and so this df is a dictionary type because we should define that in here like this one. And so in order to get the whole values in here like this one, so this df is assigned to the what the advanced math operation dataset values. Okay, and after that we can return the whole values in here like this one. Or we can visualize the dataset by using what the matplotlib library, dataset 1 and dataset 2 like this one, and so the whole values can be given in the what the item value for item in dataset 1 and dataset 2. Okay, and after that the plt is a specific function or the class structure or the libraries as the what the pyplot library, and so we can define the figure in here like this one, the fig size 10 vertical 6 horizontal in here, and plt plot can be used with what the values 1, the label is assigned to what the dataset 1, and marker can be changed with the what the O. Okay, and after that values 2 dataset 2, and this should be assigned to the what the x value, and plt title can be assigned with the what the dataset visualization, and also plt x label can be assigned to the data points, and plt y label is assigned to the what the values, and plt legend can be shown, and plt show can be shown in here like this one. Okay, these are the function, and whole function can be used by using these terms. Okay, and after that we have the specific function and we have the generalized class definition in here. Okay, so dataset 1 can be created with what random dataset 10 values and 10 values. Okay, and so results addition can be assigned with what the item 1 plus item 2 for item 1 comma item 2 in zip data set 1 and data set 2. Each dataset is assigned to the another one with some specific index, and so we can assign to item 1 item and item 2 for each case for the dataset until the what, until the end, at the end of this data 1 and data 2 set. Okay, or we can multiply by these terms like this one and this one. Okay, so write to dataset to Excel file can be assigned with what the result addition, and we can give the specific names with what the results addition .xlsx, and also we can give the what the multiplication. Okay, so if I run this code and then the whole datasets are created in here like this one, and so this xlsx file or result multiplication and addition is created in here. Okay, the total value is given, but how can we obtain these values in here like this one? Result addition can be read from the what the result addition dot xlsx or result at and result mul. It's the new variable, and we can copy off this name in here like this one. And so after that we can visualize whole the data set in the what result at and result mul. Okay, and so if I run this code and then we will have the some specific figure dataset visualization. Okay, these are the dataset with uniformly points with the what with the 0 to 80, and so we have the 10 values in here, or contain 10 values in here like this one. Okay, and so each values is assigned or stored in the what is result addition and result multiplication Excel file, and then we can write the whole the codes by using these terms. Okay, any question? This is a simple example of the what of our code in the first session of the R algorithms. Okay, so in the application session of the what on the 2, we need to forward with the what with the inheritance property in Python programming language. Okay, any question? Okay, if there's no question, and so what about the inheritance? Inheritance means that this is the allowing to the what you to create a new class that inherits properties and behaviors or attributes or the methods from an existing class. Okay, this is called the inheritance, and so there are some function defined in class A, and we want to define a new class called B, and so this B must possess the same feature like the A. And so instead of using or creating the new A variable, and then we can drive the any variable or any class by using what? The A in the what or within the B class. And so B is derived from the A or the base class. Okay, and so in literature the existence class is called the parent. Okay, or base class, and the other term, the existing, the derived class, is referred to as child or derived class. Okay, this is the basic domination or the foundation of the what the inheritance properties in Python programming language. But in real life we have, for example, every car has a tire. Okay, and so we can create the tire class. But for example, the BMW or Audi or the Cherry or the what Ford has also possessed the what the tire. And so how about defining a one tire class? And so this tire always utilized in the what in the BMW, Audi and Cherry and Ford. And so we can easily define a tire class, and so this tire class is a base class for the what BMW, Audi or Cherry or the Ford, because Ford, Cherry, Audi and BMW has always a tire. And so if we define this tire class, and so we can easily utilize this tire feature at every car or the model of this what these cars. Okay, this is the huge advantage of the what the utilization of the inheritance property. And so therefore we can define a one tire class in here, and its property can be inherited to the another class. Okay, and also we have some basic syntax in here, like this one. We have the class keyword in here, and so we need to create the derived class name. New class name should be given in here. After that, we should give the open and close parentheses in here, and then we can say the base class name should be put into this one, and then we can write the any statements as a class element after this definition. Okay. Any question? Okay. In the first example, we can create the class A like this one, and so we can define the def view, and we can call the print view in here like this one, and so we can define the another function in here like this one, the print bar, and class B is derived from the A like this one, and so B is the derived class, A is the base class. Okay, and so def tar can be given in here like this one, and so we can print the tar values. Firstly, we need to understand that if we can create the B in here, and so this A is also created in Python programming language, or in any other programming language like the C or C++ or the C#. Okay, but there's a difference in here like this one. B tar can be called in here like this one. And so tar is seen on the terminal page, but we can also reach the foo function, or we can also reach the bar function in here, because the B is the derived class based on the A class. Okay, and so B possess the functions of the A. But what about the A class? For example, a tar function can be called in here, and so this A object has no attribute as a tar, which means that if we derive the B class from the A, and so B possesses the whole function which is given in the A, but this A does not possess the B functions. Just remember that. Okay, any question? Okay, so in the next case we can create the class A in here like this one, the set A, self A, and self A can be assigned with the A values. Okay, so we can display the A function with the self keyword in here like this one, the print self A. Okay, and also we can create the derived class B, the def set B self B which is equal to the self B. Okay, and also def disp B self, and print self A and self B. Okay, but just remember that this self does not possess the A value, but if we have the derivation or derived class formation in here like this one, and so this A can be inherited from the A like this one. Okay, so how about this definition? B and B set A can be assigned with the 10, and set B can be assigned with the 20. Okay, so B this A can be called, and this B also can be called in here like this one. 10 and 20, because this self A is inherited from the class A. Okay, this is the basic notation of the base class utilization. But what about these terms? For example, x is equal to the 10. Okay, and so if we have inherit all the properties from this class notation, and so this B has also this property x. Okay, and so if we rerun this code and then we have the 10 values with the x, and so this 100 values in here like this one, and so 100 is seen on the terminal page. But just remember that this x is the point in the a, and so this b is right from the a, and then we can utilize the b to reach the x value with the values of the 100 in the print object notation in here like this one. Okay, this is a huge advantage of the derivation of the any class from the base class in Python programming language. Okay, any question? Guys, everything is clear because this inheritance is not easy topic to be understand in Python programming notation. Okay, and so if there are any question in here, and so you can easily ask me. Okay, so what about the constructor in inheritance? Firstly, we can define the class A in here, and so the constructor is called with the init function body, and so we can also give the another a variable in here like this one. Okay, and so the self a is a new variable with arguments of the a like this one, and so we can print the call the a constructor. Okay, so def this a can be given also in here like this one, so the print self a can also be given. Okay, and class B a def init can be added in here, but with some basic definition. We have the new keywords in here, super. This super means that or indicates that the base class of our notation, which means that this a is assigned with the super keywords. Okay, and so at each case this is the derived class, the b calls the a function and also automatically calls the constructor of itself. Okay, and then returns the num value. Okay, can also give the print the b constructor can be given at this time, and after that the self b is assigned to be b. Okay, and also def this b the print self b. Okay, so what about this definition 10 and 200s? And so in the first place we call the b constructor by using this definition, which means that this init function is called. Okay, and so this init function calls the super dot init function, and so this jumps to this code. Okay, and so this code is assigned to the a and print the a constructor. And so if we are using or we run this code, and then firstly we see that the a constructor and after that the b constructor. Okay, but this is the definition of the only of the b class variable, right? Do you understand what I'm saying in here? The base class constructor automatically calls with with the derived class when when it's created in the main function body. Okay, what about if I remove this code, and so the only b constructor is defined in here like this one. Okay, but this a cannot be reachable right now. Okay, and so the self dot a can also be given in here like this one, and so bear this a like this one. And so if I run this code, and so b object has no attribute as a, even if this code is true. But if I remove this super term in here like this one, and so we have the 10 and 200 values on the terminal page, and so you just remember that the derived class always should call to the what, to the superclass or the base class constructor, to what, to create the whole these variables within the what, within the B class. Okay, this is the basic properties of the what of our inheritance constructor. Okay, or we can call the A init function like this one, the self.a. Okay, and this self is possessed with what, the B, and so we must parameterize or pass these arguments to the init constructor, and so these two definitions are identical. Just remember that. Okay, any question? If there's no question, I can pass another example in here like this one. Firstly, we can create the what, the self A in here like this one, and so self.a should be assigned like this one. Okay, and so we can print the A constructor to indicate what's the next line of our code in here like this one, and so the self can be assigned with the print self A value. Okay, and then after that we can drive the B A class in here, and so def init constructor can be assigned with this term, but additionally one parameter should be added in here. And so this super function can also be used with the what, the B and self definition in here like this one. This identical with the what with this nomination. Okay, just remember that in the first case we have the super init A function body in here, and so this is also the same notation with the what, with this character. This is the what, the derived class parameter, and so this self is given in the what, the self, this instance or the attributes or the general attributes of this class parameter, and so this can be called by using these terms. Okay, and also we should give the B constructor notation, and def this B, the self, the print self B, and B can be initialized with what, the 1, 10 and 200 values, and so be this A, B, this B. Okay, and so if I run this code, and then we have the what, the B object has new attributes as B. Okay, and so what's our code wrong? This code just say that the self B should be assigned these terms. Okay, and so A constructor B constructor 10 and 20 is assigned to the what, to these terms. But what about the class utilization? Generally we have the name of the bigger B values in here. Okay, B dot disp A B and B B, and so in this definition we just say that this super function takes the what, the B class variable and this self keyword, which means that we can call the disp A and disp B by using the instance or the variables, but we can also utilize these functions possessed with the class B by using these terms. B is the generalized class name like the static class, or this B possesses the disp A, and so we can give the what, the B self operator in here like this one in order to what, in order to get these properties from the what, from this instance. Okay, and so this super enable us to what, to utilization of these terms like this one. Okay, and so these are the identicals of the what, the or are codes in Python programming language. Okay, so is there any question about the inheritance property? Okay, there is no question. So in the next session, we will create some more complex examples about the inheritance and its property in Python programming language. Okay?